key, run it through a process, and you get what's referred to as a ciphertext. The reverse of that is taking the ciphertext and the other half of that key, running it through a similar process and getting plain text out. Signatures, slightly different. You also take plain text and a key, run it through a process, and you get a signature, which you can then attach to the original data. That isn't strictly reversible. What you can do with that is take the plain text, the signature, and the other half of the key, run it through a process, and find out whether it all matches or not. So common use cases, people are familiar with encrypting email, signing email, but you can essentially use these same processes for any chunk of data. Over the years, it's been adopted for things like package distribution in a lot of the Linux distributions. Packages get signed using PGP and distributed along with keys. Yeah, so those are sort of the main things that people end up using it for. Very quick overview of this is called asymmetrical cryptography. What you have is a public key, which you can share with other people, and a private key, which you keep private. This is, again, basically the same mechanism as DNS sec. It's just the details of the implementation that tend to be a little different. So if you want to create a signature for a piece of data, you take your private key with the data, run it through a process, and you get that signature out, as I said. You can validate that by taking the original data and the signature, comparing that to the public key, and to find out whether or not it was valid or not. If you want to encrypt text, you start out with your private key, take some plain text, whatever your original data is, run it through the PGP process, and you get ciphertext out the other end. And then, of course, reversing that, you can take the ciphertext, use your private key to then decrypt it and get the plain text back. So that's all stuff that most people are familiar with, just to make sure everyone's on the same page. So why actually do a key signing? So crypto like this brings with it sort of a problem of trust. If you want to encrypt something to a particular individual, you need to be certain you've got the key that belongs to that individual. If you want to validate a signature on some data, you need to be able to be sure that the signature was generated by the key of the person or organization that it claims to be from. You need to get a copy of the public half of that individual or that organization's key, but you need to be able to do it in a way that you can be certain where it came from. So what if I want to encrypt something to a person I'm aware of but don't necessarily know personally? How do I get a hold of their key in a way that I can trust it? So this starts to look at the trust model. So say, Anne knows Bob and trusts his key, and she can generate a signature for it. Bob trusts Carl's key and can generate a signature on that key. Carl trusts Donna's key and can sign that. And so if I happen to trust Anne's key, I can follow all these signatures and ultimately, within a certain range of reasonability, trust Donna's key just by the inheritance of trust through this chain. So I can represent that as a chain of trust. So this is very similar at this point to what we do with DNS sec. That the implementation, again, slightly different, but we have the root keys signing DS records for the TLDs signing DS records for their delegations, and so on down the chain to give you this sort of chain of trust. The difference with PGP, though, is that it doesn't need to strictly be a direct chain. You can have things like maybe Anne trusts Bob and Carl, right? So you get a different path through. And another thing that happens here is typically in PGP, the trust is bidirectional. So Anne trusts Carl's key and Carl trusts Anne's key, so you can follow that chain of trust in both directions quite easily. But where it gets really interesting is when you start adding more people to this, and what you wind up with is something that looks more like this, except even on an even larger scale. And this is sort of what we're aiming for when we do key signing parties, is to take this trust relationship and make it as dense as we possibly can, so that people on different sides of the world who never meet and may never have any reason to know each other personally are able to communicate securely and trust each other's trust what's coming from other individuals without ever having to meet or necessarily trust that individual personally. And this gets referred to as the web of trust in PGP. So this is the main idea of what the key signing is aiming for. So how do key signings work? There are a couple of different ways to do them. The last few meetings we've been using a slightly modified form of what's known as the Zimmerman-Sassman protocol. As I said, there are a few different ways to do this. This one tends to be a bit lower effort, take a little bit less time. So the way this works is that people who want to participate, if they don't already have them, they generate keys, right? You put away the private key somewhere, take that public key, and you share it with your organizer. In this case, me. So you would mail your copy of your public key to this email address, pgbsign@dnsoarc.net. The organizer takes all the keys that they receive and they put them together into a key ring. So that's a file that basically has the public half of all of the keys of all the people who want to participate. Once that key ring is formed, the organizer creates a hash of it. And then either posts that publicly, reads it out at the key signing, makes it available in some way that people can trust that hash. So for example, although I'm not doing it today, we're not far enough through organizing this. In the past, I've put the hash up in this presentation. That hash, by the way, in that last slide is an example. Don't assume that's useful for anything. So then actually at the key signing party, what happens is that everyone arrives with a downloaded copy of the key ring. In this particular case, for anyone who's participating, the key ring will be posted to the meeting materials in the agenda online. So everyone can download a copy of that. At the key signing, I will read out the hash of the key ring that I uploaded. And everyone who's attending should be able to run a hash of their copy of the key that they downloaded and verify that we're talking about exactly the same file. Everyone who's participating looks at that key ring and looks at their own key in that key ring and verifies whether that key has the same fingerprint as the key they sent to me. If everyone puts up their hands and says, yes, the key in the key ring is my key, then because we all trust that we're talking about the same file and everybody there says that, yes, the key in that file is mine, then you can immediately trust that the key you've got in your file belongs to that person. And the final step is basically to make sure you know who you're talking to. A lot of us know each other, many of us don't. So there's usually a step of verifying ID and getting people to verify their email addresses in the process so that you can know that the person you're looking at who says the key in the key ring is theirs and says that their email address is such and such, and that email address matches the key you're looking at. If all those pieces of information come together, then you should be able to trust that key, sign the key, and add your own trust to that key's data. After the key party, everyone goes home and actually does these signatures. So the way this works in PGP is that you generate a signature on a key using your own key. So this is very similar to signing a DS record in DNSSEC. The difference here is that when you generate that signature, it actually gets attached to the key that you're signing. And then what you do is you email that key back to the person who you got it from. And the key contains an email address, so that's easy to do. There's a tool for doing this. It's called CAF. It gets distributed for Debian in a package called Signing Party, for Red Hat in a package called PGP Tools. Unfortunately, the last time I checked, the CAF depends on a library that is currently broken in macOS and BSD. So unfortunately, you can't install it directly on either of those operating systems at the moment. That is the quick overview of what this is and how it works. Do we still have time for any questions? 2 minutes. 2 minutes for questions, if anyone has any.
Hi, Matt. This is Anand Buttudev from RIPE NCC. I have a quick comment about software. Mm-hmm. There's a very nice Python module called Pius, spelled P-I-U-S, that also does PGP key signing, and it'll run anywhere you have Python.
Excellent.
So it's a great tool. I use it for PGP key signing, and I highly recommend it.
Great. All right. I had intended to try to throw together a quick online tutorial thing that people could look at for using CAF. So I'll check with you later to make sure I remember the name of that correctly, and I might add that to it. All right, so for anyone who doesn't already have a key, if you want to participate, you still can. There's a URL at the bottom of this slide where I've got a very quick, step-by-step of how to generate your first key. Uses all defaults from current versions of PGP, but it should be sufficient for a first-time go. Please feel free to upload keys and participate. Anyone who would like to, if you could please have your keys emailed to here before the end of the first break tomorrow morning. I will put together the key ring, and we will be doing the key signing during lunch tomorrow. So thanks very much.
Thanks, Matt. Next up, we have Olafur Guzmundsson from Cloudflare coming to talk about his experiences with DNS over HTTPS and DNS over TLS. Welcome, Olafur.
Thank you, Anand. Sorry. We at Cloudflare have been playing a little bit with D over 8s and DNS over TLS, and we figured it would be good to share some of our experiences with it and also put these experiences in context. So, on April 1st, we announced a public resolver. It has an easy-to-remember addresses that we got to use with a permission from APNIC. We are using these corrupt addresses to do our research on, first of all, how much of the internet can talk to them. We realized that a bunch of the internet can't talk to them. We have been giving talks all over the world about the reachability to it and the problems we had in cleaning up the internet. Right now, these addresses work reasonably well, especially the second one, which my marketing department doesn't allow me to talk about. But to focus on what it is that we wanted to do as a public resolver, there is other ones out there, a whole bunch of them, and we wanted to be different. And what was it that we could do differently? We realized we had two advantages. One was we have enormous scale, and we are closer to many end users than the other providers that were there before. And there is also a demand for one that is a little bit more open about what they do with the data, and to try to make it available for users to have as much privacy as they can when they are going around on the internet. And so this is what motivated us. Like I mentioned, we have locations all over the world, and this enables us to be closer to the eyeball networks, which we envision as our main customers. Not necessarily true, as we have discovered. We have got very popular among cloud users on their compute platforms. And yes, so the design goals is, well, let's take a step backwards. DNS is an old protocol on the internet, 35 years plus. And it was designed to work mainly over UDP. UDP is great until you start putting crap on the internet. Then it becomes very bad. But we're not going to talk about that. We're talking about all the malicious behavior or not so malicious behavior that goes on with all these packets that are flowing around in the clear. Whenever you send a DNS query out somewhere, anybody who has access to that network link can see everything that is going out there. There are a number of examples of people playing games with the DNS traffic, either to give you better answers or to stop you from going where you want to go or keep track of where you are going so they can sell you other stuff. Whatever the reasons are, people are doing it. We also wanted to, if we decide to say we want to build the most privacy conscientious resolver in the world, what is it going to look like? What is it that we should deploy in it? And there's a whole bunch of new technologies that the IETF has been developing or is still developing that are promising. So we decided to deploy all of them and see what would happen. The first one we have the longest experience with is the query minimization. Basically, it is that when you send a message, resolver or sub-resolver sends a message to this local resolver or whatever resolver they've configured, they send the full query name. Then the recursive resolver goes out and asks everybody it needs with the full query name. So if it needs to resolve something called foobar.com, it sends that to the root servers. It sends that to the com servers. It sends it to the bar server. In most of these cases, they don't need this information. If you don't know where com is, you just ask the root server for .com. If you want to know where bar is, you ask the com server where it is. Yeah, why did we do this the first time in the DNS protocol? Well, nobody is exactly sure. Is this an implementation bug that it is a no convention of sending the full query name? Or was it because we didn't know where the zone cuts were going to be? Probably it's a combination of both. But over the last 35 years, we have built up a large installed base that assumes this behavior. And undoing that and discovering all these devices out there that don't like it when they get question that is not for A or quad A. Like if they suddenly get an NS query or an SOA query, and they return an next domains on that. Yeah, there is all kinds of crap that it returns. Yes. The other wonderful thing that came out, which is also an old idea, is the generating negative answers from DNSSEC answers. If you have the NSEC or NSEC3 chain and you get a question, you can frequently figure out from your cache, does this really exist? If it doesn't exist and you have a proof in your hands, just generate that and send it out. And that's what we do. Also, there is this thing, if we are talking in the clear to authorities, anybody who is between us and the authorities can see what we are sending. Therefore, sending the client subnet option on that is actually quite a privacy leak. So to address that, we decided not to send client subnet to anybody. And we are thinking about how we can actually do something like client subnet in a more responsible manner than what is being done today. And I can't talk about it today, but we'll talk about it hopefully later. And then there is the other thing is how are we going to talk between the stub resolver and the recursor? And there are these two new protocols, DNS over TLS and DNS over HTTPS, and we made them available everywhere. And that is what the rest of this talk is going to be about. Yeah. So, if you want to be privacy oriented, then we have to have a good privacy policy. It has to be transparent, and we want it to be as clear as what we do. When a query hits our edge, the software components that handle the query know the full IP address. The systems that deal with logging don't see it. They only see a masked address. On the IPv4, it's a /24. On an IPv6, it's a /48. We just zero out everything below that. The only use of our logs is for looking at performance. We have diagnosed an awful lot of the operational problems from our logs. We are also looking at adoption rates. And some of the data that we have in our logs is available for APNIC to examine, to do their research or look at trends on the internet. But they are under the same hard clock as we are. 23 hours is basically the time you can expect to see the data. Because when we say it's going to be gone in 24 hours, that means we only keep it for 23 hours in our data store, because to deal with the time of getting in and the possible delays in delays in. And we have a privacy policy. We have a very strong statements about it. We are going to have an auditing firm come in regularly and make sure we are following it. If we ever make a change in how we do things, we will update the privacy policy first. No third parties other than the one that is mentioned on this slide has access to the data, period. Our other and large part of Cloudflare's have no access to it. There are very strict restrictions on the logs. There are few people who can see it, and I have a hard time getting to them, as an example. I can only access them through Grafana. And all we care about is figuring out problems and seeing trends and what's going on. Okay, implementing these. How did we go about it? Well, we built our public resolvers based on an open source resolver from the Czech registry called NOT. Those in the know probably know that the original author of that resolver worked at the Czech registry and then decided to join me at Cloudflare at some point. But we have a really good relationship with them and work on improving the software. It has not been a totally bug-free experience for either one of us, but the resolver is getting really good as we go on. It came with all of the features, most of the features we wanted built in, and we have been adding and enhancing them over time. One of the problems was it came with GNU TLS. GNU TLS is not what we would call a cutting-edge crypto library all the time. And so we have sometimes had the features that we would like to have that are not available right at the time. But it supports the thing we figured out was the most important. It allows us for long-lived connections, and it allows session resumption. DNS or HTTPS, well, we have that actually terminated by our Nginx. We wrote a special Lua module that deals with it, talks to our resolvers, and the most complicated part of that was actually making sure that the Lua module prevented the rest of Nginx to write any PII into the HTTP log systems. But we did that. And we had also adopted the Google JSON format also, which should be standardized because it's a very nice little format for queries. What are our challenges in this? Well, there are tools out there. There is growing all the time, and if you want to see the page down there, seems to be the best source of what is available. And yeah. When we were rolling out the DNS resolver on a corrupt address, we used RIPE atlases a lot to figure out whether we could talk to it over DNS. Worked great. It helped us figure out like 300 different networks that needed to be kicked, multiple vendors to be shamed, and others. But we could not test it over DNS over DHH or T because they don't support modern crypto algorithms. They are stuck in the last century RSA-only mode. I understand the latest versions support it, but we and others have discovered this. Though supported by a whole bunch of stuff like this. One of the reasons why a DOE rollout with a protocol that was not standardized when we rolled it out happened at the IETF in London at the beginning in March last year. Almost every implementer at that time was in one room working on interoperability. We had the test cases, and people were very good at figuring out where the text was incorrect, what needed clarification, and we had new drafts issued. So after that, almost everybody was fully compliant. The usage. Well, here is the important things. Is DOE good or bad for performance? If you're going to a cloud DNS provider, is there a big penalty for that versus going to your local ISP or your own? And Mozilla, who pushed us to do the DOE support early, did a performance experiment that they published. And basically, this is the below 0 is the percent of connections that have a penalty and what the penalty is. But there is a lot of queries that have a slight penalty, and there is about 20% of the queries have a significant benefit. So depending on where you are, what you are, yes, there may be a slight penalty to going for a little bit further away, but possibly getting some of the answers back much faster. The other issue that Mozilla identified in our implementation is over HTTPS, we were not allowing enough channels for them to do all of the queries they wanted to do in parallel. And that's another issue. DNS over TLS, we have basically had no complaints about that anywhere except from China. And the main reason for that is all of our servers are located outside of China. And somehow answers from us over UDP get there faster than light, and I don't know why. Most of the traffic that we are seeing on this, we think, comes over in bursts. So some entity like a browser goes in and it is resolving a page. And that may result in 50, 60, 200 queries. Comes in, session goes away, blah. So the overhead of TLS or TNS or TCP is not that high. All of the clients that support session resumption lower this overhead even further. So we believe, after our experiences with this, it's going to be a great thing to have TLS, DNS over TLS, between recursors and authorities they talk to a lot. It gets rid of a number of the network issues between us, and it also helps protect us against route hijacks, which have become another problem, and that's not going to be talked about today. Yes, here's a question that everybody asks me about the connection reuse. What is it? I'm sorry, I can't answer it. It violates our privacy policy to log that information. But the other thing I want to say, we are going to get some number on this because we have been talking to a few authorities we talk to a lot and doing DNS over TLS to them. And I can't talk about who at the moment, but there are some really good numbers that are coming out of that. Thank you. George.
Hey, the TLS to authorities. So the trade-off feels like it's trading configuration burden to make it work, and the upside is persistent state means less transitional TCP buffer state in kernels, because to some extent they're getting TCP load now, aren't they? So if they move to persisting TLS sessions, they're not consuming random amounts of kernel memory, bringing up and dropping TCP bindings, but they have this administrative burden that the two parties have to agree we want to do this. Or are you trying to move to a world where you don't have to pre-agree, you just taste it, and if you can succeed in a TLS, you turn it on and use it? How do you see this working?
The later. Optimistic, opportunistic. If it works, it works. Right now we are configuring which ones we talk to, but eventually we want to go away from that.
I think it's a nice model. I think that a lot of the background noise about, oh no, we can't have the burden of move to TCP, I think those problems go away if you have a persisting, no, but if you have a persisting session state between a resolver and the authority, that whole question of scaling, it goes away.
Exactly. You only go to one, because one of the reasons why queries are scattered so much in UDP is to deal with the forgery issue, giving you extra bits in the query ID, which is totally unnecessary if you go to connections. Yes?
Oh, hey, Aaron from Amazon. So I read the blog post about 1111, and I have not seen, or I don't remember, the metrics, the service owner metrics, let's say. So you have enabled the TLS,
yes.
and you have a metric before and after TLS. So what are the implications of CPU memory and the resolver benchmark, let's say under 1 million requests per second? So do you have any data on it?
Let's just answer it this way. The overhead is so small, we don't care.
Okay, but how so small? And like, I mean, if I have thousands of servers, I wouldn't care to put 100 more, you know. But if I have 2, I would be, you know, thinking about it. So, you know, it all depends.
It all depends, yes.
Yeah. Okay.
Yeah. No, I don't have numbers that would be meaningful in your context or others' context.
All right. Thanks.
Hey, it's Alex Band, Anonet Labs. You say you anonymize on /48 IPv6?
Yes.
Yeah? Do you think that's private enough? Because that is what I get to my house. And you might as well just not.
I don't know.
But it's quite common for ISPs to give /48s to home users.
I thought most of them gave out like /56 or 64s to home users.
Yeah. Well, I have a very regular access row connection in the Netherlands, and it gives out /48. Just saying.
Okay, well, I'll take that into advisement.
Sorry, Dave Lawrence. You might want to check into work that Dave Plonka is doing on this. He's done a lot of very interesting research on ways to anonymize IPv6 address space and tracing the different uses of it. And so he's already got a couple of white papers out on it, and that'll probably give you a lot better guidance for how to anonymize.
Thank you.
Sarah Dickinson. A sort of connected follow-up question. You said you do additional obfuscation before you share the data with AppNIC.
Yes.
What's the methodology behind that?
Mostly it is to hide how many servers I have in each location.
So you don't do any additional obfuscation of the IP address?
No.
Okay.
They get the same IP addresses as we see, they just don't see what server handles it or how many servers I have.
So they're still getting the same subnet cutoff? Okay. You talked about obfuscating PII. Do you consider the HTTP headers to be PII?
We don't log them on the connection, yes.
So there's no record of the HTTP headers associated with the DNS requests in your logs?
Can you repeat that? Sorry.
So there's absolutely no logging of any of the HTTP headers associated with the individual DO requests? So
No.
you don't log user agent, language, none of that?
None.
Okay, thanks for clarifying.
John Reed. So I have sort of a meta question, which is, you know, you mentioned right now we have obviously the decentralized DNS infrastructure, hierarchical, and now we have a large DO provider with close integration with a browser. I think the average end user is not even going to look at this setting or care about what it is. What path do you see from getting from where we are now to a world in which DO is largely ubiquitous without ceding a large amount of control to a single provider?
That's a really good question. I don't know exactly what the best way to that. Basically, there are going to be a number of DO providers around the world, and And a really privacy conscientious user would probably select 2 or 3 of them in their settings to scatter traffic, and then the user should be able to see what are the privacy policies of each one of these providers and pick based on that.
And do you anticipate the average user? I mean, yeah, I think we're more privacy conscious in this community than we would be elsewhere. But you know, if the goal of this is to essentially provide better anonymization and privacy and prevent misuse of data for the global community, are they going to be looking, you know, the same people who just click accept after a 5-page TOS, are they going to be looking at this? Are they going to be able to make that decision?
Okay, I'm going to date myself by the answer I'm going to give you. In the early 2000s, I wrote an RFC which had a statement in there that there is no way for an end device to discover the policy of the resolver it's talking to. So until we have totally automated and make it verifiable that you can check out what a resolver is going to do, and it will actually do that, I don't see any way to automate how you connect to it. So it is going to be some kind of a configuration decision. Sure. Which ones is selected.
Sure, and then just, I don't monopolize, but just the flip side of that is, I think a lot of consumers, at least in the US, have indicated they're willing to give up privacy for convenience. Lack of EDNS 0 end user client subnet might mean that their connection to a CDN is not as efficient as they want. Do you plan to give users the option to say, actually, I'm fine sending my ECS information because I'd rather have a faster website and I don't care if they know what my /24 is?
One part of our experimentation with the talking to upstreams is, can we possibly then give a client subnet over trusted links to the upstreams? Okay. So it never becomes, it never goes in clear text.
So there's a plan to have that discussion
we are doing research and thinking about it, because there are places like in the world where they have one connection and they have a box from some big content provider inside, and if the questions go to our resolvers, they may get a server that's far away, and it costs them a lot of money to get it. Yes, we're aware of it. And also, if we look at the internet as a whole, some addresses have privacy issues with them. Others have absolutely none. Think about the carrier-grade NAT addresses. Can you predict when you go on your cell phone that is talking IPv6 to an IPv4 NAT, whether you're going to have the same IPv4 address for 10 minutes?
Right, yeah.
Okay, so.
Yep.
So the privacy, to a large extent, with relation to addresses, is largely a first world problem, because the network providers there have an address, lots of addresses to use. In IPv6, what's going to happen? I don't know, but we should be talking about this in the whole context of what is possible and what makes sense.
Yeah, thank you.
Weber Akamai. So okay, I'm going. Okay, so first thing, the experiment that you had there, that was DNS only, or was it also the resulting HTTP request or whatever comes up?
The experiment that Mozilla did was to compare the speed of getting the DNS answers from the locally configured resolver versus our resolvers.
Okay, so it's pretty much.
It did not have to do with the eyeball.
Because that might be different depending if you are on the network or
yes.
others.
Yes.
And the second question is, I mean, it's privacy related. So you have servers in lots of countries.
Yes.
Where do you actually store the data, and how do you deal with the regulations that you might encounter in these countries?
I think the question you are asking is what is called in policy circles data sovereignty. Yes, and that is above my pay grade. Right now, we store this in our core data centers in 2 places.
Okay, so 3. It's kind of consumed from the world, probably to somewhere in the US, right? Am I correct in that?
Next question. Sorry.
Tony Finch, University of Cambridge. I'm glad to hear that you're talking to people about DNS over TLS to authoritative servers from recursive servers. The DNS privacy working group in the IETF has been talking about this for a number of months without a great deal of external input. So it'd be great if you could encourage the people you're working with to contribute to the IETF and help us not to go off into the wild weeds and get it wrong.
You may remember I was one of the members of the working group that voted for waiting before starting that work, because it's better to do a little bit of experimentation and see if it works and before we start talking about the bits. Yeah.
Thanks.
Yeah, so it will happen. Bert.
Hello, Bert Hubert, Power DNS. So I promised you this question, so I will now ask it. Why?
Why? Because we can. But to be serious, we saw a need that lots of alternatives to locally provided resolvers were very far away from people and took a long time to get the answers. We also noticed that there is not much discussion about what happens to the data. So we wanted to have both of these issues addressed, and we saw a way to do it.
So will Cloudflare soon merge with the EFF? Big privacy fighter? I mean, do the Cloudflare shareholders get up in the morning and say, we need to improve the world's privacy?
We work quite closely with the EFF.
Yeah, okay, but are they your shareholder now?
No.
Because, to be honest,
sorry, I don't know.
There's probably a lawyer listening into this call. No, but
one more.
Yeah, more. I mean, it's a laughing matter, but you make some very interesting statements. For example, you say you don't know the policy or the privacy policy of your current name server provider, because
That's
it
right.
cannot. I do know the privacy policy of my current name server provider because I have a thing called the GDPR, and it's written down.
Yes.
And it's valid, and it's the law.
Yes.
And now this American company comes up and says, hey, let's work on getting your DNS to our servers for your privacy. And when we ask, where is this data located? You go like, yeah, I cannot tell.
That's fair.
And I love you, Olafur, I really do. But it is not funny to me when someone comes along and says, well, I have this slightly incoherent story. I ask your CEO, I say, why are you doing it? Are you getting paid? Is someone paying you? And he said, no one is paying us. We're not paying anyone. We're doing it out of the sheer goodness of our hearts.
Yes, that's true. I can tell you that.
Did you check that with the lawyers?
Yes.
Okay.
This is a cost to us. It's not a profit center.
Okay. I'll wrap it up now, but Anand, you make me lose my train of thought. He said, and that's my final question, he says, we are doing this so that our authoritative servers become faster. Can you explain what he meant by that?
Well, if I'll pick on a random person here from the room, like if Matt is sitting in his house and he uses our resolver and he wants to go to whatever cat picture site that is on us, yes, our resolver gets the answer from the authority from the same location, so the answer gets to him faster than if it had to go across the ocean to get it. Yeah, so it speeds up the people who are paying us to deliver content around the world. Makes them faster.
Okay, thank you.
Thank you very much, Olafur, for this very lively presentation. Next up, we have Dwayne from VeriSign, and he's going to talk about changes to some of the TLDs that VeriSign operates.
Yes, thank you. So hopefully this will go pretty quick. Just wanted to give you a little update about some upcoming changes to TLDs that VeriSign operates. Really want to cover three things. Increasing the length of some zone signing keys, talk about TTLs, and then something that we call cross-zone glue. Okay, so ZSK length increase. This graph shows all the TLDs spread out on the horizontal axis, and they're grouped by colors, and the height represents the length of their keys. So you can see way over on the left, there's a few TLDs that are not signed at all at this point. Then there's this sort of small red blob, which is RSA SHA-1. There's an orange blob, which is RSA SHA-1 with NSEC3. The big green blob is algorithm 8, RSA SHA-256. There's a little bit of RSA 512. And then if you look really closely at the very end, you can see there are currently 2 TLDs using ECDSA algorithms. So currently, the VeriSign TLDs fall in the green blob there at 1024, and in the future we're going to bump those up to 1280, which is the other sort of shelf that you see there off to the right in the green. So as I said, currently all the TLDs that we operate use 1024-bit RSA keys. The root, of course, has had a 2048-bit ZSK since October 2016. All of our TLDs will be increased to 1280, with the exception of ARPA. ARPA is the one TLD that uses NSEC instead of NSEC3. So for ARPA, we'll go to 2048, just like the root. This will be gradually rolled out for different platforms that we operate, tentatively starting later this quarter and extending until about a year from now. So we chose 1280 because for NSEC3 zones, that key length keeps us under certain fragmentation limits. This graph shows the results of some simulations that we ran. We took some query data that we received and then replayed it to zones signed with the larger key sizes. And this is the distribution of responses. The horizontal axis goes from 0 to about 1600. That's the size of the DNS response message. And then the y-axis is just a cumulative distribution function. The different colors here represent different types of responses. Green, for example, there's a little bit of green. Those are unsigned NX domain responses. Then the red ones are unsigned referrals. The blue, which is most of them, that's signed referrals, and then the purple ones up at the top are signed NX domain responses. And for the most part, we stay well below fragmentation limits. In this result, there was some sub 1% number that was actually above that, but that's fine. Okay, TTLs. So currently, all of the VeriSign operated TLDs have a 48-hour TTL on all the delegation data, and it has been this way for as long as any of us can remember. We have been asked about changing these TTLs, lowering them to something other than 48 hours. At this point, we have implemented this in code, so we have the ability to change TTLs per TLD. We're still considering doing this for some low-volume TLDs, and if and when we do this, we will do a sort of a gradual decrease. We won't go from, say, 48 hours to 1 hour. We'll do it in steps and monitor very closely. So lastly, cross-zone glue. What we call cross-zone glue happens because, for example, both .com and .net are on the same platform. And if you have a name server for a .com name, but the name server is actually in .net, currently you get this you'll get the glue record with the .net name, and vice versa. Most implementations that we tested actually ignore this sort of out-of-zone glue. With one exception, Google Public DNS currently does not. We feel that's not really an issue, though. It's sort of harmless. In the future, the referrals for .com and .net will only contain the in-zone glue. This one benefit to this is we have slightly smaller responses, and this will allow providers to use dynamically addressed name servers within .com and .net. This we expect to be deployed later this quarter, so relatively soon, actually. And that's it. Happy to take any questions if there are some. I know that was pretty short. I don't know if your mic is on, Oliver. Is this mic on? No. That's why everyone was lined up over here before.
Oh, Ola Gunnarsson, Cloudflare. Wait, thank you for thinking about lowering the TTLs. They are not suitable for modern internet.
Thank you for keeping that short.
Roy Arendt, are these slides going to be available?
I guess that's a program committee action, yeah. Okay.
Okay.
The program committee says they are available now. Maybe when you looked before, they were not quite.
Yeah, I looked 3 minutes
unblocked.
ago.
Yeah. Okay.
Dynamically addressed name servers. Can you explain what that means?
Right. So let's say you have a.com, and your name server is b.net. Okay. So today we would return a referral for a.com that says here the name server is b.net, and here is b.net's IP address. Okay, a fixed address which is published in the zone file. You might want to have b.net's IP address change depending on who's asking or where you're asking from or the time of day or whatever. And you could certainly do that, but today, since that fixed address is included in the referral, it's sort of questionable whether it would actually work. Okay. Does that make sense?
That makes sense.
Okay.
Thank you.
Hi, Dwayne, Jim Reed. Have you done any modelling on the impacts of the changes of the TTLs? Is it a simple calculation that if you half the TTLs, you're going to double the number of queries to authoritative servers? Have you done any modelling of that? Have you got any data that suggests what the impact might be?
Yeah, we haven't done like theoretical or simulations or anything like that. Our intention is to do this gradually and then measure the effects. So do it sort of empirically.
Okay.
Right, but we don't. I couldn't tell you today. I know that other folks have done this exact thing. Was it .nl?
Yes.
Yeah. So they have data on this from when they've done it. We don't have data, and I don't have other analysis at this point.
Okay.
Yeah.
Thanks.
Jaromir, CZNIC. Can you go back to the algorithm slide?
This one?
Yes.
Yeah.
I think I was checking it on my laptop, and the too far right, they are RSA SHA-512, not ECDSA, but it's just I think this is just a small, really small, tiny row which is not assigned to any TLD yet, the ECDSA. But the question is, do you have some control over the algorithm these TLDs are using, or can you enforce to change for TLD to use different algorithm, for example? Or
Yeah, so we have not considered using any other algorithms or changing algorithms for the VeriSign TLDs. Currently, all the VeriSign TLDs are RSA SHA-256. They're all algorithm 8.
Okay.
And we're not proposing to change those algorithms at this time, so we're just proposing to change the key size.
Okay, and so these are algorithms of TLDs, and they decided themselves?
This is all TLDs, not just VeriSign TLDs.
Oh, okay,
this is the whole zone.
Yeah,
there are labels on the horizontal axis.
So that confused me. I thought it's hosted by you or something.
Okay, yeah, this is the whole root zone. Yeah.
All right, thanks for the presentation, Dwayne. Just one comment regards to the previous question. If someone was looking for about what happens to the traffic when you reduce the TTL, Martin Volink, my colleague, did a presentation a couple of OARC meetings ago, and I don't know exactly which one, but pretty much .nl half the TTL horizon, and that the traffic didn't double to us. So the numbers are there. I don't remember by heart. Now my question is about TTLs. I'm actually working on this particular topic right now. I mean, we're going to present something tomorrow on caching and their relationships between TTL and caching, how much gets cached. But I'm trying somehow to understand why people choose 2 days on not one day or whatever reason. So I'm trying to figure out the reasons, and it's not that clear to me, and even on .nl. So if you have any thoughts on that, or
Yeah, I think that there's a lot of just inertia. I think 30 plus years ago, when people sat down and did this, they said, well, 2 days seems good. And it just never got changed since then. And we've talked about this a little bit within, for the root zone, there was a study that we did a couple years ago, and we saw a lot of sort of reluctance to change it if it ain't broken. So I think it would be good if there was more research around this. with you know, as Ulfer said, with today's modern internet in mind, and what is appropriate for today's internet versus 30 years ago. Yeah. All right. Thanks.
Thank you, Dwayne. And up next, we have Jaromír Talíř from the Czech Registry to talk about their experiences with ECDSA. Welcome.
Thank you, Anand. So, yes, sorry, that was my confusion about the previous diagram, that I thought that there are some other ECDSA TLDs that I'm not aware of, but still there are two right now. I was checking. So I want to talk a little bit about how we get to this situation. So it's a story. So every story starts with long time ago. Fortunately, this part of the galaxy, we deployed the DNSSEC for the CZ in 2006, and as probably everybody at the time, we decided to use RSA SHA-1. There was, I think, like 5 TLDs at the time. And we actually waited for the first KSK rollover until the root zone got signed. So our operators need not to switch twice the KSK, the trust anchor. So 2010, we did our first KSK removal, and we decided to use RSA SHA-512 with NSEC3. And it was actually the first algorithm rollover in TLD space. And at the time, nobody knew anything about the liberal approach and conservative approach. So we did classical KSK double signing method. And unfortunately, we have got a call from Olaf Kolkman quite soon that the unbound is not validating .cz. Surprisingly, it was just only call at the time because the penetration of DNSSEC was quite low and everybody was using bind at the time, so we didn't get any more complaints. But at the time we have realized that it's not easy to do algorithm rollover. There are some necessary steps like pre-publication of signatures with the new algorithms and things like this that are described in the that were described later in the RFC. So. After 3 years, we did our second KSK rollover. This time we didn't change algorithm. We only split the administration of ZSK and KSK into 2 teams, similar to what IANA is doing with all these key signing requests and responses. And 3 years later, we decided that our next KSK rollover will be to ECDSA. Unfortunately, at the time, RZM was not ready to accept ECDSA algorithm, even though there were a lot of presentations that this algorithm is suitable for being used at DNS. My former colleague Andrei had the presentation about this at the fall of 2016 at the DNS OARC workshop as well. So we concentrated for the next year at the second level. We published the stats for algorithms used in our zone. We met several registrars that were interested in ECDSA and convinced a few of them to switch to ECDSA with all of their hosted domains. So during the year, suddenly ECDSA became the most used algorithm for .cz zone. It's not seen quite well, but on the 4th place there is ECDSA algorithm 14. It's P384, I think. So there are another 60,000 domains that are using also ellipticers. So in total, ellipticers have something like almost half of the signed domains for .cz. And this includes some quite really high-profile domains that are hosted on these registrars. So at that point of time, it's quite can be seen that there is we can switch to ECDSA without any fear that somebody will be harmed. We are trying over the whole year, every ICANN meeting, trying to talk to IANA whether they will be updating the RZM to allow ECDSA algorithm to be put into the root zone. Finally, in October 2017, it happened. The change was made to RZM that allowed new algorithms. However, there are still some algorithms that are already in IANA tables as allowed algorithms, but they are not allowed in RZM. Well, I think that may be a problem. I'm not saying that somebody wants to have these Edward curves published in a root zone yet, but if there will be time, that we probably should not wait another year until the RZM will be updated. So it was possible to do that. We decided to do that with conservative approach. So because we have the experience from our first rollover that we should be more conservative than when we were. And it should be carefully tested because we had this split scenario with the request signing from ZSK team to KSK team. We decided to schedule it for 1 week in June and did some operational updates about the times of zone publication and maximum UDP response sizes, because we expected that there will be some upgrade or some extension of the response size. So we didn't want to respond all KSK responses via TCP. Here is the 5-step description of all the 5 steps of conservative algorithm and the 3 interesting numbers that we were tracing. At the beginning, zone publication time was about 15 minutes. It's all together with the zone file generation from the registry, signing, and publication to the hidden master server. So we started with this. The first step was the publication of ECDSA algorithms. So you can see that the zone file has changed a little bit, also the response size, and also the publication time. The second step was publishing the ECDSA keys. Here you can see that the size of the responses got over the previous set, over these 1232 bytes that we have set as maximum UDP size. And the publication time got to 29 minutes, so it's close to our previous 13 minutes publication time, so that's why we have changed the publication time to 1 hour. And this was also the step where we have got one information that one guy sent us over Twitter information that his unbound stopped validating.cz, but it was the only one. I will get to that a little bit later. Then we changed the DSR cross. There is no change in timing. That's I can say that it was done in about like 1.5 days by IANA, so it was quite quick. And then we start to remove the old stuff, like removing old RSA keys and removing old RSA signatures. At the end, you can see that the publication time stopped at 22 minutes, and the most significant change is the size of the DNS key responses. So first conclusion that we have, that if you do conservative approach, doesn't mean that anything breaks. The situation was that was described by the guy that called us, that he has opened WRT with the real old unbound, and it failed to validate .cz. I was trying to trace the changelog, and the liberal validation appeared in 1.4.7 and ECDSA support in 1.4.17. And this version is 8 years old. However, actually this is the version, this old version is why we are doing this conservative approach, which means that actually doing conservative approach doesn't help for this old software, because there are probably some other bugs that may be connected with the combination of ECDSA and that so it may happen that if there is the old software, it will break even with conservative approach. And the second conclusion is speed of the signing. Even though we expected that it will decrease, it's actually increased. We are using DNS sign zone from by 9/11. Maybe that's something that is connected with that. There are some validation checking during the signing that it's internally validates that the signing is correct, and everyone knows that the validation of ECDSA is quite time consuming, so maybe this slow down the whole process. We received some suggestion to use the new versions where there is a rewritten signer, but we have not did that yet. And so general conclusion is that we think that it's safe to use ECDSA for a TLD, and which was confirmed by .br that turned to ECDSA soon after. And that's it from me. So thank you, and I will be happy to answer any questions.
Any questions? No? Okay, thank you, Jaromír. Thank you very much, Jaromír. So next up, we have a 1-hour discussion slot about the recent event, the root zone KSK rollover. And for this discussion, we're going to have some presentations, and I would like to invite to the floor Matt Larson and Pete Barber from VeriSign, and Matt Weinberg is doing a presentation as well. And we're also going to have a presentation by Moritz Müller from SIDN Labs. Yeah. Good. Thanks, guys, for volunteering to take part in this discussion session. We're going to start this session off with a presentation by Matt Larson from ICANN about the rollover in general. And we're going to follow that with some questions and discussion, and then we'll have the other presentations after that. So welcome, Matt.
Do I need to stall? Tell a joke.
Perhaps you should take a year to gather more data.
How long do I have to kill time here? There's nothing like 150 people staring at you to make you forget every joke you've ever known. Yeah. All right, cool. All right, well, I don't think there's anybody here who doesn't know what happened 2 days ago. It was the culmination of a multi-year process to roll the root zone KSK for the first time. So the penultimate action was in late September or mid-September. The ICANN board passed a resolution that authorized the ICANN organization to go ahead and roll it. And that was 2 days ago at 1600 UTC. We rolled the key. And the actual process of rolling the key was the publication of a new root zone that for the first time the root apex DNS key RR set was signed with what we've been calling KSK 2017 when it had previously always been signed with KSK 2010. So it was that zone publication that actually implemented the KSK role. So that was 45 hours ago. And this is an informal overview of what happened. So here's the minute-by-minute schedule of what happened. 3 hours in advance, we took our time. VeriSign generated the root zone file. They did their own set of tests and validations. They sent it to ICANN. We did multiple different tests and validations. You know, normally this is an action that everything is automated. The zone file gets generated, and I can't speak to VeriSign's processes, but at least on the ICANN side, there aren't humans involved in inspecting it. But we thought for this particular time, we all should take a really good look at it and make sure we were happy with it. So we did that. We built a lot of time into the schedule. So there was, despite it being sort of a momentous occasion, there was an awful lot of sitting around staring at each other while while various people were doing things and other people were waiting. But we inspected the zone file various different ways. We decided everything was okay. We had a formal go, no-go call within ICANN. The various parts of ICANN all agreed that, yep, we all thought we were ready to go. And Joran Marby, our CEO, said, okay, go ahead and do it. He authorized it. And then a little more waiting. So we, right for the top of the hour at 1600 UTC, so 6 p.m. local time here. And then VeriSign published the zone, and that was it. So, there's not a whole lot to say. It just happened. So we did this from Amsterdam because we all wanted to be here, and when we realized the timing, it was like, well, we can hardly roll the key and then get on airplanes. So we all came here and did it from a room at NLNet Labs. So a huge thanks to NLNet Labs for providing us their conference room, and that's all of us there sitting around. That was where the magic happened right there. You're looking at it. That young guy on the lower left is holding a copy of the signed root zone in 2010 when we signed it for the first time. And so we had a dramatic recreation of that on the right. So I actually, on the left, I'm literally holding the signed root zone because this was before the GTLD expansion. And on the right, I am not holding the complete signed root zone, which would be like 350 pages if you printed it out at this point. I don't know how to. This is an animation. I don't know how to hit play on here. Does that make it go? That makes it go. There we go. All right. So take a look at the upper left there. What you can see is Can I do it again? Yes. No? Yes. So what you're looking at in the upper left is data from all the root servers' DNS key queries per second. And that's the main thing that we noticed was that, and this is what we expected based on understanding how various validators behave when they become unhappy with a stale trust anchor. They query more frequently in a desperate hope that they're maybe going to see something different. And so as expected, the volume of DNS key queries went up, presumably from validators that still have the old key and are trying to get the new key. As you can see, the overall magnitude, while it was about a doubling, we're not talking in terms of absolute terms a lot of queries. Nobody has reported anything directly to ICANN. I mean, I guess that's the big news here. I think as everybody's aware, really very, very little has happened, which is what we were hoping for. We've seen sporadic reports. Basically, you all have seen everything we've seen because nobody has reported anything directly to ICANN. There's been some old software, the Bloodhound version of Firefox. We knew it was old code that had the old trust anchor burned in, so that didn't work. DNSSec validator from CZNIC is also old, no longer supported code that had the old trust anchor configured. So both of those were known to be issues. The Debian DNS Ruby package, the maintainer had updated the trust anchor back in July, but Debian hadn't actually repackaged it until last night. So now that's been updated. We heard sporadic reports of some, ironically, some monitoring tools that were not updated. But no broken resolvers. We haven't had anybody say, "Oh, I had," even a handful of users unable to connect because the resolver they were looking at was broken, let alone hundreds or even thousands of people. So it's really been a very pleasant non-event. And right now, as I say, we're 45 hours into it. So because the DNS key TTL is 48 hours, so for anyone who didn't cap that at a lower value, which we know a lot of resolvers do, presumably we are hopefully out of the woods in another 3 hours, and anything that would have broken would hopefully have broken. So that's all I have to talk about. I don't know, Anand, is the plan. I'll just turn it back over to Anand.
Thank you, Matt, for that quick and nice presentation. I'd like to invite people to come up with questions or, compliments or other things that they want to say at this stage. Yep, there we have some questions.
Well, while people are gathering at the mic, one thing that I neglected to say was that, and I meant to get this across on the title slide here, that a lot of people at ICANN and VeriSign worked a long time on this. So I just want to acknowledge that many people, and also the community. We had the root KSK role design team that went away and thought about this, and we largely implemented the plan that they came up with. So the point is, like many big projects, I'm just the guy that gets to stand up and talk about it, but there are many people who did a lot of work. So I want to acknowledge everybody who's had a part in this all this time.
All right.
So Warren Kamari, Google. So I think many people know that I was expecting this to go a lot worse. And I just want to say I'm really glad that I was wrong. And, hats off to you for doing this so well. And, more to say.
Yeah, thanks very much. What Warren said, I think there's been a lot of hard work behind the scenes. Personally, I think a lot of that stuff was perhaps unnecessary. I think a lot of the stuff was really just to give everybody in the community the sense that there was more than excessive due diligence being done to make sure that nothing bad was ever going to happen. And that was a necessary thing to do, even if from an engineering or technical viewpoint, it probably wasn't needed. I think it was good to be prudent and to be demonstrated to be prudent and careful. So my congratulations and thanks to everyone that's involved in this. I have a question though. Now that we've rolled the key for the first time, when are you going to do it again and how often?
All right. Who's got the right? I hope everybody's been tracking on your cards. So the answer to that question is that this is the beginning of the community discussion that's going to need to happen. This is not something that ICANN is going to unilaterally decide. We would like to help facilitate that discussion, but ultimately, like other aspects of the ICANN bottom-up multi-stakeholder process, this is going to be a long discussion to figure out exactly how we want to do this. Right now, the guidance we have is the guidance we've had all along, which is that the DPS, the DNSSEC practices statement document, currently says after 5 years. Now, that document can be amended too. That's not chiseled in stone. But in terms of what's written down, what we have for policy, that's what we're going by. So really, the point is we have a blank sheet of paper to decide what happens next, and it's the people in this room and others who are going to help that discussion move along.
Okay, a quick question, which is mostly because we have so much people in this room. This is an unprecedented gathering of DNS knowledge, and I'm also here. But many years ago, many moons ago, I was with Olaf Kolkman in a sort of a DNSSEC preparatory meeting before the root got signed, and the signing of the root was growing imminent, and it would now really happen. And then we recalled that there was a plan that once the root got signed, we would roll the key like within a few months just to practice it, just to make sure that we could do it. And this seemed like a super prudent plan. And we looked at each other, and Olaf and I said, but that's never going to happen. And this is my memory from that time. But I've tried to find this glorious plan of sort of quickly rolling the route so we were sure that it could be done, which would have been very interesting. But am I the only one that remembers this, or was this ever originally the plan? Shane says yes.
I remember it being discussed. I don't ever remember it being written down. I mean, there, like many issues, there are strong feelings on either side. I was one of the people on the other side who said, you know, I don't think we should do that. But I remember that there were heated discussions about that. But I'll defer to other people's memories in the room as well.
Okay. Well, at least so at least there was it's good to know. And again, I know there will be many congratulations. But now, of course, the first roll we did was a very high stake one, with hundreds of millions of people actually doing DNSSEC validation. So, again, congratulations for doing this high wire act now.
Sorry to go back again, Jim Reid. I'm worried a little bit, Mark, you say that perhaps the DPS is suggesting doing the next key rollover in 5 years' time, or there'll be some sort of, there'll obviously have to be some understandable community consultation on this. But if we're talking about something in that kind of time frame, I'm kind of worried that when we get to do the next key rollover, we're still no further forward from where we are just now, because we may well find in that length of time that people have hard-coded in the new KSK, and we'll be back in the same situation exactly as we were in just now, because we didn't know people had hard-coded the old and about to be retired KSK.
Right, well, I want to be clear, I wasn't suggesting that the next one is in 5 years. I was just saying in terms of what's written down, the only thing written down is that policy statement in the DPS. And and the DPS is malleable. So the point I was trying to get across was we truly have a blank sheet of paper.
Yeah, but the point I'm trying to make here is that if we leave it a long time, and I think it's going to be inevitable if we have an ICANN consultation on how long the next interval is going to be before the next rollover, and so on, all this other razzmatazz and stuff that goes on about it, we could be something the order of 3 to 5 years from where we are just now. I think that's a reasonable estimate. Now, my concern is that if we leave it for that length of time, people are going to hardwire the current new key, and we're going to be back in the same situation we were in just now when we did the first rollover, because we're going to have unknown things out there in the network with a key that can't be changed.
Yeah, well, one thing I can say is that people have probably heard me say this. People have asked, well, when are you going to roll it the next time? And my answer had always been, please let us roll it the first time before we start talking about that. So I will honestly say we have not given a lot of thought to the process for the discussion. We really just truly wanted to focus on getting the KSK rolled. But I hear your point, and I'm sure you're not the only one who thinks that this is something that we can't just sit on. So clearly, the discussion has to happen. This is not something that we'll do multiple ICANN meetings from now. It's something that needs to start very soon.
Yeah. Okay, thanks,
so
Mark.
your point taken.
Benno Overeinder. Well, I actually want to start a discussion now. We are the community. So my suggestion, at least once a year. Then it's the process, frequency.
Once a month.
Yeah.
I don't think there's a bingo slot for once a month.
So I do have a serious question, though, which is how many roles before we could converse about algorithm change? Because I feel the value in the new algorithm, which was very definitely suppressed, not at the same time. Don't do the first roll with the new alg. I think we have to talk about algorithm and frequency.
Andre?
So, well, to partly address what Jim said, we have learned our lessons also in the, this is Andre at ISC, and the software got a little bit better due to the first roll. So we now have the Sentinel, we now have Trust Anchor Telemetry, which may got implemented more servers. So it's not like that we are in the same state as we were before the first roll. So I think we improved, and I do agree with Georgette.
Did you play it? What was the term what was the bingo term? The last one. What? Annually for the win. Okay. Please continue.
And I do agree with George that we need to start a discussion on the algorithm role. If we have a good algorithm that's supported out there.
Warren?
So, Warren Kumari, seeing as we're talking about all the stuff we should do for the next role, we should also sometime discuss having standby keys, right? This is a whole other big can of worms that we should have a discussion somewhere, but Mike St. John, for one, always believed that standby keys was the right thing to do, and then hopefully future roles are less painful. But
I will point out that if we had had a standby key from the beginning, there would have been considerably less drama.
Yep. Yeah.
Roy Ahrens?
Roy Ahrens, I work at ICANN, but this is my personal opinion. Just want to make that clear. There are three discussions, indeed. One is frequency, one is algorithm role, and the other one is the standby key. All three discussions are important to have, but they are somewhat intertwined. A little bit about frequency. We can't really do this any faster than 3 months, and this is due to a ceremony we have every 3 months, where we basically have, where we create those new keys. No, sorry, where we sign the ZSKs that vary sign roles every 3 months. Then there's something to say about the time we did this rollover, which was the October the 11th. This was also planned last year on October the 11th. From the three main events during a key rollover, the middle one, which is the 11th of October, which is when we use the new signature, is the important one. This is where things can break. The other main event is when we introduce a new key, and the other main event is when we revoke the old key. Now, October the 11th is particularly chosen because January the 11th is right after the holidays. The 11th is also important. It's the day after the first 10 days of a new ZSK. Then April the 11th, Easter in many countries, and July the 11th, holidays in many countries. So October the 11th seems like seemed at the time like the date that have most operators available. So once a year sounds good. However, if we stick to once a year, and we do a key rollover once a year, then when are we going to do the algorithm rollover? When are we going to introduce a new standby key? So that kind of limits it to once every 2 years. Again, this is my personal opinion. I would love to hear what the community has to say. I know there are many folks that think like, why roll over at all? Why did we do this one? I'm not part of that group. I think we need to roll over a little bit faster than once every 8 years as we did now. I would say if we throw dates around, once every 2 years at least.
Jeff?
Jeff Houston, I sort of pinged on that comment about, well, we've learned so much, and I actually think we've learned almost nothing. None of us actually are able to measure in advance what was going to happen. RFC 8145 was a signal that was, if I was to be generous, ambiguous, realistically, it was all noise and no signal. It threw us off by a year because we didn't understand, and we still don't understand what that signal means. The work on the Key Sentinel, I was only measuring resolvers that had changed their software in the last month. I'm like, what you're really worried about is stuff that's sitting in closets for years, and that's not going to change next year either. So all this confidence about, well, it happened and nothing bad went, so let's go and roll the algorithm, is false bravado. We actually have no idea on how to measure these aspects of the DNS in advance of doing it. And it's really good that we went over a crack in the ground and it wasn't a cliff this time. But that doesn't give you any assurance that the next crack isn't a cliff. And I suppose what I worry about is that while the measuring set of this is so primitive, and while our tools are based largely on, at best, guesswork, and more likely just finger in the air, then this stuff will always smack of bravado. And the person who's saying every month or every year, to my mind, sounds a bit crazy, because we honestly don't know what we're doing, and we're lucky. Now that's great, but that's all we were. We were lucky. So just understand, nobody knows in advance with this particular kind of question in the DNS. We can't see it, we can't measure it. And every single time you roll it, particularly the algorithm, you're going to take that step into, oh my God, I hope it's going to go okay.
So, Jeff, are you suggesting that or perhaps it's a question for the panel here, like, do we need more changes to our software to do even more monitoring and reporting before we go off and think about rolling keys again?
I was measuring stuff that had been upgraded a month ago and it was reporting good. What do you reckon? The stuff we were worried about was stuff coming from a Red Hat distribution, you know, sometime in the dim, dark eons of time that was running a resolver no one even remembers. No matter what we do in the future, that old stuff will still be running. And that's the kind of the uncertainty factor. And what we really don't understand is how many users are hanging off it. So to some extent, I suspect that this is a difficult problem that we can never get over quickly. And that would be an argument to say, if we are going to change the measurement technique and the protocol, you know, and I'll go against the crowd here, maybe 5 years is a good time. Because if we are going to look at more changes in the specs of resolvers to betray their trust anchor status in a way that makes sense, as distinct from 8145 that didn't, then you're going to take some time to get it inculcated, deployed, have Bert agree that it's not another straw on the camel's back and actually do it. But we need that if we're going to measure it. Or you can simply go, oh hell, let's just do it next year and see what we break. What sounds more responsible?
Brian Dixon, GoDaddy. I'm coming up with an answer to some of the questions, or I think what the thing we need to do is add more tools to the tool set, one of which would be the ability to do a rollback. I think the next time we do a roll, we should also test the rollback so that any new changes we do, we have somewhere to go if something bad happens. So don't actually revoke the old key, publish the new key, and then publish the old key again as a way of rolling back. Just a suggestion off the top of my head, but I'm thinking if we have that tool in the tool set, then we can worry a little less about what happens if we try and do an algorithm roll.
So I think the old key is already, is still in the root zone, isn't it?
Yeah, so we actually have rollback plans, and at any point can pull the trigger and go back to signing with the former key. And since we haven't revoked it, you know, only the people who have manually decided to yank it out too soon, frankly, would be affected. So yeah, the plan all along was to have the ability to roll back if we needed. So the point is we can. The point is we can.
Okay, good.
I'm going to cut the mics after this, so these people who are at the mics can ask their questions. Joe next.
Hi, Joe Abley. So Brian and Jeff both had, I think, good examples about what I wanted to say, which is I think there's a ridiculous, tense fog of fear around the fact we might break the internet from following standard protocols and well-documented operational procedures and actually doing what is correct. And I think it seems to be based on some understanding that the internet, as it normally functions every day, is a perfectly well-oiled machine, and it's possible that we might break that machine and the whole internet will fail. And I'm not sure where this idea comes from, but I think the internet is a giant, turbulent sea of chaos filled with shit. And the fact that it works any day is a miracle. People fix things that break every 5 minutes of the day in every ISP in the world, and this is just one more thing. I don't think the idea that every ISP, well, I'm saying there's a balance. I'm saying sometimes if you add, for example, the kind of complexity that says we should test the rollback, and not only roll to the new key, but then roll back to the old key, and then maybe roll to the new key in a week, and then back again, and then we can all sort of turn around and generate a new key which is deliberately broken, and test that. And these are all ridiculous things to suggest, in my opinion, because I think if we just follow the process and the standard and make it as simple as possible, when things break, and some things definitely will break, they will get fixed. Just like there's a reason why ISPs have help desks. It's not just because end users are stupid, it's because things break and need to be reported, and they get fixed. So let's not pretend that the internet is some perfect beast that we're about to cripple. It's already staggering around on broken legs, and it still works. And let's just bear in mind that just following the rules and making it simple is perhaps the best way.
Matt?
Matt Poundset. First thing, I'd like to thank Joe for making my question much, much shorter, because I was going to say most of that. I think Jeff had some good points, but I think we have demonstrated that a role is relatively safe so far. We still have a couple hours of TTLs left to find out for sure, but you're right to say that we don't know what will happen if we do an algorithm role. We have no data on that. But I don't think we need to fear it necessarily. And so my question is, obviously nobody's really thought about this much yet, but I would appreciate a little speculation. When do you think we can stop having these conversations and make a key role or an algorithm role a purely operational decision of the root zone management team, whoever that happens to be at any given point, and not a massive community debate? Second role? Third role?
Hey, Tail. While I normally love Jeff's pessimistic charm, I think in this case it is impractical because it is the perfect being the enemy of the good. And so essentially what I'm saying is a recap of everything that Joe just said, in that we live in an imperfect, heterogeneous internet that's just never going to have all of the cases accounted for. And yes, we haven't done perfect measurement on it, but we've done a pretty good job of measurement on it. And to the extent that we set up an operating environment where this is one of those things that's expected to change on a regular basis, that addresses a lot of the problems that have been seen with people who expect it to be static on a very long-term basis. If you're a package maintainer, you're on notice now that this is the kind of thing that can change, and your old package coming up should be able to cope with the change. So I'm a big proponent of saying this should just be, and as Matt just said, kind of operationally normalize it so it doesn't involve, spinning up the entire community on it every time, and just a normal part of business doing it once a year. So.
Thanks. Matthijs?
Matthijs, DNS Oracle. There's a saying in the Netherlands that is, the lawn is already mowed, and that is now the case for me, because when the lines are cleared, basically everything I want to say is already said. Yeah, I'm going to say it anyway. Keep it short. You said you didn't want to have the discussion on the next algorithm role the next role how often we should do it. Turns out we're having this discussion anyway, so I'm gonna say I am in favor of following the DPS that is set there. That was like 5 years, if I remember correctly, and so I think you should do it in 5 years' time. Yeah, and I also don't think that you were lucky. I think there was a good preparation in here, and sure, things break. There's always that power DNS guy that never upgraded and was lying under a rock, and then thought, oh shoot, I should have added a new key. But those are, in my case, incidents, small incidents, and overall it went very great. Thanks.
Evan has graciously given me one quick moment. I think all I have to do is say RSA, and then that gives me bingo. So I don't know if there's a running list somewhere.
Okay, a final comment from Evan.
Evan Hunt from IC. Much the same things as the previous 4 or 5 people said. Jeff pointed out that we don't have a lot of knowledge. We didn't in advance have a lot of knowledge of what's going to happen, but the things that we're worried about were old resolvers sitting in a closet that were installed with very old keys and weren't rolling to a new key automatically, and all of those have now already broken. The odds of somebody now going and getting an old version of some broken old resolver and installing it in a closet next week so that it will break again the next time we roll don't seem super high to me. But for those people for whom one spank is not enough pain, I do think that we should probably consider rolling as often as practically possible. For a while, maybe not forever, but rolls every year for a while would probably clean out anybody left who was going to be that kind of undisciplined. So, anyway, thanks.
Thanks, Evan. Thank you, everyone, for your comments and questions. I'd now like to invite Moritz Müller from SIDN Labs to present about the stuff that they were observing during the roll.
I'm part of the Root Canary project, which had the idea basically to have a canary in the coal mine for the actual KSK rollover. And this is a collaboration with many partners and collaborators, and I work for SAN Labs. So our methodology, at least for this rollover, was we used the RIPE Atlas probes that are out there, which are roughly 10,000 RIPE Atlas probes. And for this presentation, I'm going to talk about two measurements, basically. The first measurement is measuring queries for the RR-sig of the root zone. And the other two measurements were for one bogus record with a bogus signature and one with a valid signature. And with that, we wanted to see if resolvers are failing during the time of the rollover, and how the signature is getting picked up by the recursive resolvers. And of course then spam Twitter, so you might have seen some of our charts coming by. And for those who don't follow Twitter, we also posted our figures on the NL Labs website as well, just to reach out to more people and to let them know what's going on from our perspective. So first I want to talk about validation errors. So this is data basically from this morning, more or less. And what we see here is the green line, which is the resolvers which were validating before the rollover. The rollover is the blue vertical line there. And resolvers which weren't validating before the rollover. And what you can see there, nothing changed. So at least from our perspective, this was a very good sign, and resolvers who validated before the rollover still kept on validating, and resolvers who failed before that kept on failing because they were probably broken anyways. If we look a bit closer at this data, we see actually there was some small changes there. So note that the y-axis here is quite different. So on the left side you see the responses, the no error responses for valid signed records, and you see that there's a slight drop for resolvers who got a no error for the valid signed domain name, and we got a slight increase for the surfails. I think it's like 0.1% of vantage points who then reported a surfail after the rollover, actually. This line could, in theory, still increase, but we have to see what's going on. So who's failing? I just looked basically at the local resolver that was configured to the RIPE Atlas probe. So we didn't look at what the actually upstream resolver was, but just what the resolver is that the RIPE Atlas probe has configured locally. And there is Google on top of there, but I'm not saying that Google failed during the rollover. I'm saying more that the RIPE Atlas probes used a lot of Google resolvers. That's just like a thing in RIPE Atlas measurements. And this is why I guess Google is also up there, but I think there were some other things broken in there as well, and I don't think that Google failed, I guess. So what I did was to look in where these RIPE Atlas probes were actually located, and maybe this says a bit more into what went wrong there. So we have a couple of ASs which pop up there more often than others. But then again, also for example, the network of the Deutsche Telekom, there are quite a lot of RIPE Atlas probes, so this might be also the law of big numbers. But this might be an indication that there were some issues in some networks, but this is something that we still have to look into. I basically did this analysis this morning, so there's still a lot of future work to do. Then another figure was to see when did the recursive resolvers actually seen the new signatures. And this is also data from this morning, and we can see we are almost at 100% for the new signatures. So that means that most of the resolvers picked up the new signatures. But we've also seen a lot of weird bumps in these graphs. And what I'm trying to do in the next few slides is to explain why these bumps actually happened. So this is the expected RR-sig expiration before the rollover. So I looked into the TTLs that I've seen before the rollover date. And then I calculated what would have been the time when the signatures would have expired. And we see this big spike, which happened actually a few hours ago. And we see a few other bumps down there. And if we look at a public resolver, so we've seen the resolvers probes that used Cloudflare had expected RR-sig expiration of like at the very end of the rollover. We have OpenDNS, which explains this small bump over there. So they have apparently had their expiration roughly a day after the rollover. We have VeriSign resolvers, which are also quite prevalent, which were also at the very end. And the Google resolvers also were expiring more at the end of the 48-hour period. So in total, I can't explain all of the bumps yet, and I think I especially can't explain like this huge jump between 5 o'clock and 11 o'clock yesterday. I can't explain that yet, but this is still future work. But apparently there must be some big resolvers expiring there and picking up their new records. I also seen some resolvers who have an expected expiration of the TTL after today of 4 o'clock. There are only very small numbers, and I think you can find the figure on the website. I haven't included that on the slide yet, but there are still some resolvers that hold on to the signatures longer than the expected time. That was basically it. The rollover went fine from our perspective. Now we want to dive more into data. We also want to look at the diddle data, and we're also, of course, open to other research questions as well here. Thanks.
Thank you very much, Moritz. I'd like to actually start with a question of my own. In your earliest slide, you said that you're querying for RR6. So just to be clear, were you explicitly querying just for the RR-sig at root or DNS key and then extracting the RR-sig that you got back with the answer?
We did both measurements, but in this case, I'm looking only at the query where I directly query for the RR-sig.
Okay, because when some of us were looking at some of the popular caches, we observed, especially with Google Cache, that if you ask for the DNS key with DO bit set, you got one set of answers with the old RR-sig, but if you explicitly asked for RR-sig for dot, you were getting the new one, okay, which is probably to do with the way Google's caches work and all that. I mean, we don't know the internals, but maybe asking that question was perhaps not quite accurate or reflective of what was really happening, I think, from the end user's perspective. So I just wanted to...
Okay, that's a good point. We have the measurements, so this is definitely something that I will dive into.
Okay, thanks. We have a question from Roy.
My question was actually the exact same. I sat down yesterday with Warren Kumari from Google to drill down on exactly what happened, because I saw all the signatures being from the new key when I asked for RR-sig. While others on the Jabber channel like, nope, you're wrong, and they were looking at the DNS key with the old RR-sig, and so Warren could explain that clearly yesterday. Not asking him to do that now, but there's an answer for that, why the difference is there. The other thing is, it was actually really helpful for us as well in that room to see that graph. And other labs also put it on their front page. Yes. And so that saved us watching the Twitter channel. So that it was really helpful. It was really cool stuff. Thank you.
Welcome.
Thank you, Roy. Warren?
So Warren Kumari, yeah, that was a really cool graph. I saw a lot of people watching it and looking at it. That was nice. Another sort of interesting thing, which I don't think we saw in here, but got observed in a number of places, is a spike in A queries shortly after the key rolled. And this is shown up in a bunch of resolvers and similar things. Spike in A queries, which then sort of like trailed off. And initially that caused some concern. And it seems like what that was simply aggressive NSEC caches saw that it was now a new key and managed to invalidate their aggressive NSEC cache. And so some info or some queries that were being suppressed leaked out. It would be really interesting if somebody wanted to analyze that and see sort of if that shows good deployment of aggressive NSEC and how much it's actually keeping things quiet.
Thank you, Warren. And a comment or question from Olafur?
Can you go back to the slide where you were talking about the values from Cloudflare?
I can't, no, sorry.
Okay, basically if you were looking at the values you got back by asking RR-sig, they're totally invalid.
Okay.
Totally. We don't use them. The secondly point is we have a public interface point into the resolver where people can go in and purge data, and somebody went in and purged our key data, so we are a big part of the big bump in the beginning.
Okay.
Thank you, Olafur. I think we have to go on to the next presentation now. Sorry, Peter. So I'd like to invite Matt Weinberg from VeriSign to tell us about something interesting they observed.
So my name's Matt Weinberg. I work at VeriSign. My colleague Pete, I want to ask you a question. Pete, what's your resting heartbeat right now? Right now? 70. He says 70. So this picture here is right before we push the root zone. And right before that happened, Pete turns to me, and he has his watch says what his heartbeat is. And he says to me, "Matt, my heartbeat's at 100. I'm really nervous." True story. Okay, so let's go to the presentation. Okay. Okay, so here to talk about trust anchor signals from custom applications. This all started when we received an email a month or two ago from ICANN telling us that we were emitting trust anchor data that showed that we were only using the old 19036 KSK. We take accusations of problems very seriously at VeriSign, especially when they come from ICANN. So we looked at this a little bit further. How could this be? ICANN did publish all IP addresses that they saw that were emitting this data. And sure enough, when we looked at one of our ASNs, 7342, we saw a few instances of our IP addresses sending this trust anchor signal. So we wanted to know, how could this be? We do run our own recursive service, and those IPs were associated with our own recursive service. What did we do? We were really scared, right? Were we doing something wrong? We started looking at our own servers, checked our configs, checked the trust anchors that were configured. Everything looked okay. And we just couldn't figure out initially what the problem was. So then we started thinking, what else could this be? What if the signal didn't actually originate from us? Could it be something out there that was querying us, and we in turn were sending that signal to the root servers? So, time to packet capture. Did a quick packet capture, looked for some of the offending queries, and tracked down one particular IP address. We, obfuscated the IP address here, and saw that, yes, in fact, they were querying our recursive servers with the signal of only the old trust anchor. We, in turn, were relaying that query to the root, which is how we got the love note from ICANN. So we started looking at traffic from that IP address. I don't know if you can see that there. And there were a lot of queries there for moneropulse.net, co.org. And we started saying to ourselves, what is this? Is this Monero the cryptocurrency? And in fact, it was. So there's a cryptocurrency, a very well-known one called Monero. It's the 10th largest in terms of market capitalization cryptocurrency out there. It is an open source project. libunbound is a dependency of the project. And they do signal via 8145 trust anchor data. It turns out that Monero was, in fact, using only the old trust anchor. We looked at the source code. When I say we, I mean Dwayne Wessels. And we found this little bit of code in there where they had hard-coded, as you can see, only the 19036 trust anchor. Okay? Dwayne ended up taking the client and running it on a local instance, and he saw that it was, in fact, emitting 8145 data upon startup. So that was it. What does Monero do, though? Does it break, per se, if they're doing DNSSEC validation? Well, in a quick review, we saw some places where it does do DNSSEC validation, particularly for client updates. But other places, it wasn't there at all. This really is not to throw shade at Monero. I mean, they should actually get credit for trying to use libunbound and trying to do DNSSEC validation. But their area of expertise is probably blockchain and not necessarily DNS. So there's some logs here. You can't really see it too well, but basically what it's saying is there were some complaints about DNSSEC checkpoint records were received, no two valid records. So that's where it was doing DNSSEC validation. So we opened up a GitHub issue, and they told us, sorry, it's already a duplicate of another issue. We looked at that issue, and we've been outscooped by Roy Ahrens by 10 days. Roy had opened up an issue with the project and basically told them that, hey, you need to update your code. I subsequently went back and forth with some of the developers in Monero and advised them things that they should be doing, and there was a little bit of trepidation, and they were unsure about really what the significance was of not only updating it, but the timing as well. So anyways, why are we here? Thoughts and lessons. 8145 trust anchor signaling perhaps did not fully anticipate signals from applications versus validating name servers, right? So in this case, Monero was using libunbound and doing the queries itself. It's good that there are some people out there that did this. KSK Sentinel wouldn't help in this case either. How should applications that do this keep trust anchors updated? It's not necessarily that easy. In the case of Monero, they ripped out the trust anchor from a different portion of code from Unbound, what is it called? The libunbound anchor, because the trust anchor itself is not included in libunbound. And so what's the best way of keeping that up to date, especially for people who maybe are not as savvy with DNS? Can it be improved? What's the best way of doing this? I don't have an answer. It's really more an open-ended question. I'll drop my smoke bomb and run out of the room here in a second. Also, applications can send trust anchor signals, but that doesn't necessarily mean that they're doing DNSSEC validation, right? So in this case, they were using the latest version of libunbound, which sent the signal, but doesn't necessarily mean they were validating. That's it. So, any questions?
Right, we have a question from Andre.
This is Andre with my Debian hat on. So what Debian does, there's a package called DNS root data, which distributes the root keys. And I know that Red Hat is doing something similar because we talked with Paul Walters for a couple of times about this. And I think this is the way how to do that. The operating system should provide the trust anchors,
right?
And then update them like in a timely manner. So that's the right way to do it. It shouldn't be the applications, because you will always have that one last hard-coded trust anchor somewhere. It should use the data from the operating system.
Right.
I guess that's a little bit like the certificate authorities that some OSs ship with and browsers and other applications can make use of. Mm-hmm. Thanks. Ralph?
Ralph Dolmans, Analog Labs. Just to clarify, Unbound should only send out those signals when you do validation. So that's also for a libunbound case.
Is that a question or a statement?
That's a statement.
Okay, got it.
Thanks, Ralph. Roy?
Roy Adams, another question. You happened to mention my name during the presentation. This was something I talked about during the IPG in Montreal. What happened was Warren Kamari at one point said, have you reached out to the development community? And we said, how do we do that? And he said, well, look at GitHub. And I just did a string search. And I said, cool, can you send it to me? Which he did, and I put a wrapper around it so you can automatically send issues to all of those implementations that only had the old key. So there was about 1,400, about 700 had the ability to issue issues. But I didn't have, at that time, enough bandwidth to deal with all the feedback. I dealt with the immediate feedback, but good that you guys took up Monero, because the feedback that I got is most of the time, yeah, go away. A few folks actually said, no, you have no idea how crypto works. You don't understand DNSSEC. So I was thinking at the time, who am I to discuss this with them? But yeah, those kind of interactions, we had a lot of them.
Yeah,
So-
I did something similar on GitHub, and there are a lot of crypto coins that are actually forks from Monero, and they
Yeah.
all stole the same code, and they all had the same problem as well.
Yeah, cool. Thanks for that.
Joe?
Joe Abley. So this question of where you get your trust anchor from if you're an application is an interesting one, I think. I think the idea that the application should provide it is great if you assume that the operating system is going to be updated. And that's more true for some operating systems than others. So you may be just shifting the problem there from applications that don't get updated towards operating systems that don't get updated. So so this is a pretty question for the room, not for the panel. But there was a draft that Dave Knight and I wrote about 300 years ago about how to bootstrap a validator with a trust anchor. And it kind of described what the designers, I think principally at ICANN at the time, were thinking in 2009. And it makes Mike St. John very angry. He gets very animated and makes you feel very sad when you're standing behind a microphone talking about it. So it's kind of stalled. And I still don't really entirely understand Mike St. John's philosophical objection to it, but I do think there's a gap, and it needs to be filled at some point. So I think it would be a shame if we continued to overlook how you bootstrap the trust anchor in an unattended system, because I think that is something that is only going to cause more problems. And it'd be nice to have a solution.
Thanks, Joe.
John Reed, Akamai. Thanks for sharing that, because we had a similar hair on fire situation. We got a similar notification and ended up tracking it down. And while we were discussing that internally, I know, as you just said, the whole point of the trust anchor signaling was to identify misbehaving recursives, and we have this idea of what a recursive is. And we were discussing, internally as we were tracking this down, should we be passing those queries along? Is it, some guidance about that? I mean, there's arguments both ways, and you would not have found this without that. But for additional, if we ever do any sort of in-band or out-of-band, depending on how you think about it, signaling like that, additional guidance for recursive operators about what to pass from stubs would be helpful. So.
Right.
Thanks. So Pete, here's a question for you. Since it's now public knowledge that you pushed the button, have you taken out some extra insurance? And, are you wearing a bulletproof vest or?
Yeah, there's the way the root zone management system works at VeriSign. It requires 2 people to actually push the root zone, and it's kind of like war games. It's 2 keys. It's the same idea. So I was the first key, and Pete was the guy who took all the hard effort that you all did and hit the enter key.
Cool. Thank you very much, Matt. And with that, we come to the end of this discussion session about the root zone KSK rollover. We now have a coffee break for half an hour from 4 to 4:30. So please come back in half an hour. And there is an administrative message. If you wish to take the boat from the Okura to the social this evening, and you haven't already registered for it, then you need to do that ASAP. There are a few spaces available, but you need to register as soon as possible, before the end of this break. Thank you, everyone.